Okay, this is going to be a as quick as possible set of directions for a Johnstone's triangle, just because I don't expect a substitute to have ever used one of these before. But you guys, first off, need to decide whether you want to do this set of Johnstone's triangles on your own or in a group. And we're going to have the sub pause the video, and you need to go get a sheet of Johnstone's triangles for your group. So if you're working on your own, get one for yourself. If you're working in a group of 2 or 3, that's probably the maximum, is 3 people. Then you need one sheet for your group, and you're going to put all your names down on that name block line. So you squeeze them in, okay? Pause the video, ready, go. Okay, so what we're going to be doing is we're going to be taking these 2 chemical reactions and putting them into those Johnstone triangles. So these both came from your rainbow worksheet. That first one up there is a decomposition of silver oxide into silver and oxygen. So what I want you to picture here is a silver spoon that's really tarnished, so it's kind of blackened on the surface. That's your silver oxide. So this is that black substance on the surface of tarnished silverware, silver jewelry, whatever. When it splits apart, decomposes, it creates pure shiny silver and oxygen gas. Okay, so we're going to come up here to our first row of Johnstone's triangles. And remember that bottom right-hand corner of each one is our symbolic corner. So that's where we're going to actually put the pieces of the equation. So right here, I'm going to put Ag2O. Okay, so silver oxide. Over here, it's breaking apart into silver and oxygen gas. So those are literally all we're going to write in those corners. Please write exactly what I wrote there. I get weird things in that corner sometimes, and I wonder why. Please write exactly what I wrote there, okay? That's our symbolic observation. Okay, macroscopic. Again, this can be your interpretation of what you would see at the macroscopic level. So some kind of tarnished silver. If you want to draw a spoon or a fork, color, shade it in as dingy black, okay? That's our silver oxide. Here, you're going to draw the same thing, but now shiny, because we've removed the oxygen and we're back to just shiny silver. And then, get creative on what you want oxygen gas to look like, because it's colorless gas. So I don't know what you want to draw in that box. We'll see. Okay, but this is the box that I really want to focus on, okay? What does this ionic compound look like at that submicroscopic particulate level? I do not want to see only 3 atoms in this picture. I want to see, if you zoomed into your tarnished silver item up here, what would you see? And you're going to see lots and lots of particles, not just 2 silvers and 1 oxygen like our symbolic, but you're going to see that ratio. So keep that ratio in mind when you draw the particulate level here, okay? And then again, what are you going to see here for silver? Keep in mind what physical state that is, okay? And what are you going to see over here for oxygen? Again, what physical state is oxygen? That needs to be a part of what you put in this box, okay? Obviously, well, hopefully you remember, we don't want any letters in these submicroscopic boxes. I want to see particles. So use a couple of different shadings or colors to represent your different particles. Okay, the other reaction is a combination reaction. So we have oxygen and hydrogen combining to form water. So again, we're going to come down here to the bottom of your worksheet, and I've got the plus sign, the arrow. So this is our chemical reaction. So here we're going to have oxygen, okay, plus hydrogen, and it's creating H2O. Okay, if you want to go back in and, even better symbolically is we could put in the physical states of these things so that will help you when you are drawing your particulate level of these items, okay? So there is your symbolic level. Again, oxygen and hydrogen are colorless gases. I don't know how you want to draw that, but I'm pretty sure you can come up with a good picture for water. And then here we're looking at, what do these particles look like? What is happening when oxygen and hydrogen combine to form water? What do they look like before? What do they look like after? There should be a difference between this box and this box over here, okay? Oxygen and hydrogen do not look the same at the particulate level, but they are very similar, okay? So get a couple colored pencils or use some different shading techniques. Get that all filled in, turn it into the basket. Again, we're just trying to see where your head is when we're talking about particles. Thanks.